Hello friends, welcome back to our channel. So today we'll see one more application of greedy method, that is dijkstra algorithm. So someone will call it as a dijkstra or dijkstra. Okay, so today's topic is dijkstra algorithm. So using greedy method. So we have seen the greedy method. What is a greedy method? So selecting the best or optimal solution from a solution set is called the greedy method. And here the dijkstra algorithm means finding the shortest path from the source vertex to all the remaining vertex in a graph. So we know that a graph is a connected edges for all the vertices. So for that particular graph, so finding the shortest path from the source node or source vertex to all the remaining vertices. So this is also called as single source shortest path. Single source shortest path. So the main aim is to find shortest path from source vertex to all remaining vertices in a graph. So this graph can be directed or undirected graph, right? So this can be directed graph or undirected. So this algorithm will be suitable for either a directed or undirected. So before going to this one, let's have a small introduction about the graphs. So graphs will be having vertices or vertex and edges. So vertices are represented as a circle and edges are represented with a arrow marks. So this is a directed and this is a undirected. So if you are directing towards some particular vertex, that will be represented with this arrow, and if you are not directing, it will be like this arrow. And weights. So for every edge, so this is the numerical, right? For every edge which connects two vertices will be having some sort of cost, or we call it as a weight. Example, a graph A, B, C. So here we are not using this directed, right? This is an undirected graph, and it becomes directed if the graph is in this way. And here the weight of this particular edge which connects the vertex A and vertex B is represented with a numerical. So this is a numerical. So this is called as a weight. So 5 and 4. So this will be calling as a weights, and this will be calling as a edge, and this will be calling as a vertex, and we can also call it as a nodes, or we can also call it as a hops. Okay, depends upon the subject course. So vertex, node, or hops. So this is a small introduction about this graph. Now the single source shortest path will find, first we have to find out the source node. Let it be, this is a source node. For example, this is a source node. Okay, don't get confused here. I'll write source, right? Source is A. So from A, what is the shortest path for all other vertices? So A to B, A to C. Okay, so that we have to find using this single source shortest path. So where it will be used? So it will be used in order to find the shortest distance in between one place to another place. And also the same thing will be applied in a networking concept for routing a packet. So it will find the shortest path, and through that shortest path the packets will be transferred. So in many applications we'll use this dijkstra algorithm. So dijkstra or dijkstra algorithm, right? Whatever it may be. Now we'll see what exactly happens in this single source shortest path using this dijkstra algorithm. I'll explain with a small example so that you will be understanding, right? So I'll take it A, B, C, D. So this is an undirected. So this dijkstra algorithm can be applicable for both the directed and undirected. I am giving the directed, undirected. So I will give the values 4, 10 and 15, right? So 5 is the weight given for this edge which connects vertex A and B. 15 weighted edge between B and C. 10 weighted edge between C and D. 4 weighted edge between A and D. So this is a vertex, this is an edge, this is a weight. Now we need to find, so this is a source. Let us assume this as a source. So we need to find the shortest path from A to B, A to C and A to D. Okay. See, usually A to B there is only one edge, that is a 5, and A to D there is only one edge, it's 4. What about A to C? So A to C can be done through D or through B. If A to C from B, the cost will be 5 plus 15, total 20. And if you use this path, that means through D, it will be 14. So which will be the minimal shortest path? So in order to reach C, A can travel through D, which gives the minimal cost. So here you can see we are having a multiple solutions. From this multiple solutions, we are selecting the optimal solution, right? So that's why we call this as an application for a greedy method, right? Now we'll see the procedure. What happens first? Okay, so step one, find out the source node. Find source node. Find the source node. So in this example, let us assume source is A. Source is A. And step 2. Initialize the weight of or the cost of A, that means the source is 0 and all other nodes cost is infinite. So initialize cost of source is 0 and cost of other nodes or vertices is infinite. So I'll give the weights here itself. Okay, I'll give the weights here. So I'll represent with black, small difference. So 0, and here it will be infinite and infinite. So this is a cost. Okay, don't confuse. This is a weight and this is a cost. So from source, how much cost it takes to reach the destination. So here A is the source, and if A is the destination, the cost is 0. And if B is a destination, let it be, assume it as infinity, right? So next, step 3. Okay, so find cost of neighbor vertices from source. So what are the neighbor vertices? So B and D. So how we can say that B and D are the neighbors and why not the C? Because there is a connectivity between A and B and A and D. Okay, so if it is a directed graph, consider the outgoing arrow marks, not the incoming arrow marks. Outgoing arrow marks. So if it is a directed, right? Now the neighbor edge or neighbor vertex will be D, not B, because B is connected to A, but not A is not connected to B, because this is a direction, right? So in the absence of this arrow, that means this is a undirected graph. So we can say A to B and A to D, both are the neighbors. So A is having a neighbors of A to B and A to D. So find out the cost. So there is direct connection. So obviously A to B, the cost is a 5, and A to D, the cost is a 4. Right? Now change the cost. Initially, so next. Step 4. Change the cost on vertices, or you can see update the cost on vertices. Now you can see initially, so how we can check means the minimum of see what happens here, the cost plus weight of that particular edge, comma, existing cost. So we need to consider any one, minimum of cost plus weight and existing cost. See what happens here, A to B is a 5 and A to D is a 4. So there is a direct connectivity. So we have to go with either 5 or infinity. Okay, so here in this example you can see A to B means 0 plus 5. So here the cost is 0 plus weight is 5, comma, infinity. So among this we have to find out the minimum. This is for A to B. And similarly A to D, the minimum of 0 is the cost plus weight, 0 plus 4. 0 plus 4, what is the initial cost? Infinite. So in both arguments we need to consider the minimum. So obviously it will be 5 and obviously it will be 4. Hope you understood now. Okay, now we need to update the cost on vertices. So simply remove this one. So remove this one and update it with D, 4, right? And update this one with 5. Okay. So this is a 4 and this is a 5. Okay, 4 and 5. Now what happens? Right. Next. Step 5. What we have to do? Now place the visited node in a set, visited set. For example, I mean here we will write a visited set. So write down the set. So what will be the visited node? A, because we have considered A with the shortest cost, and then okay, so and then we are updating the neighbors. So this node has been visited. So once the node is visited, we need not revisit that node. Okay, so that's why we are placing the visited node here. Now step 6. Consider vertex with minimum cost. Minimum cost. Now the cost, this is already visited, so we need not consider this one. Consider the cost of B, which is 5, C infinity, D 4. So these three are unvisited links, okay, unvisited vertices. So here we can have B with a 5 cost, D with a 4 cost, and C with a infinite. So among these we have to find out the minimum cost as a source. Now we can change. We can select that one. So among this we can simply say D with a cost 4, which is a minimum. Now consider this one as a visited, okay, because this is the shortest cost among these three. So now add it here, A and D, okay. Then step 7, update the cost on neighboring vertices. So what are the neighbors? So this has been completed. We are selecting the source as node D. Now we have selected A, and now we are selecting D. What are the neighbors for D? So one is A, there is a direct link to A, right? But A is already visited, so we need not bother about this one. We are having only one node, that is C. So D to C. So what we have to do? Update the cost based upon this one. Minimum of cost plus weight, comma, existing cost. So here you can see existing cost is infinity. So what we have to do? So minimum of cost. What is the cost of D? 4 plus weight 10, comma, infinity. So which one is the minimum? So obviously it will be 14. 14 is the minimum. So update this one with 14. Update this one with 14. Okay. Next, what we have to do? Repeat the same process from step 5. Okay, sorry. Step 6 and 7. Repeat the same process. Step 8. Repeat step 6 and 7. Step 6 and step 7 until all nodes becomes visited. So we have to repeat the same steps. So what is the step 6 after step 7? Consider vertex with the minimum cost as a source. Now consider the source. So these are the visited, right? We need not bother about that. So these are unvisited. Now consider the same 14, C14 and B5. So C14 and B5. Which one is the smaller? So obviously this is the smallest node. Consider this as a visited. And update the, what happens? Update the cost on neighboring vertices. And one point is important, that is no need to go with the visited nodes. So what are the neighbors of B, A and C? A is already visited, so we need not bother about that one. Go with the C. So what is the thing we have to do? A minimum of cost 5 plus 15, comma, 14. So the cost, existing cost is 14, right? So minimum of 5 plus 15, comma, 14. So what happens? This is a 20 and 14. So this is a minimum. Already the cost is minimum. So you need not change the cost. And then repeat the same thing. So add here B. right? And repeat the same thing. Consider a vertex with a minimum cost as source. Only one node is there, that with 14. So consider the same thing and go with this one, right? So what is the order we have done? Simply go with the order. First we have seen A as a source. From that we have visited the D. From that we have visited the B. From that we have visited the C. Okay, D to C, right? D to C. And this is the minimum cost tree. Minimum cost tree. So this we call it as a tree because this is not closed. Okay, this is a open. So this we call it as a tree. So like this we have to apply the single source shortest path. Okay, so first I'll repeat once and I'll close. So in our next session we'll see one more example, right? So first consider any graph, any directed or undirected graph. So I am taking the undirected graph. So first select the source. So that will be the single source, and our aim is to find shortest path from the same source to all the remaining vertices. So here I am taking A. So we need to find out the shortest path from A to B, A to D and A to C. Now first initialize the cost of source as 0 and other vertices as infinity. So first 0 and other cost is infinity. So find out the minimum cost vertex from all the vertices. So we are having A is a minimum because it is a 0. So consider this one. And now find out the cost for all the neighbors. That also unvisited neighbors. Okay. So find the cost of, here I'll write unvisited neighbors. Unvisited neighbors. Okay. So A neighbors are B and D. So B with a cost 5 and D with a cost 4. And so A is completed because already the neighbors have been got a cost. So A will be considered as a visited. So we need not bother about A. Now we have to update the cost for each and every vertex. Now again the same process repeated. So we need to find the vertex with a minimum cost. So here 4, some here it will be 5 and it is a infinity. So 4 is the minimum cost. So we have to select the D and again repeat the same process. Find out all the unvisited neighbors and find out the cost and repeat the same until all the nodes or all the vertices have been visited. Right? So one thing, so here we are having a 2 paths in order to reach the C from A. AB, BC, AD, DC. That means we can have multiple solutions, and from that multiple solutions we are taking a constraint as a shortest path based upon the cost of the edges. So that's why we can say this dijkstra algorithm is an application of a greedy method. So which gives the optimal result among the several solutions. Right? So hope you understood this one. Let's stop here. In our next session, I'll go with a few examples so that the complete clarity will be getting, right? So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.